And here's the back page. That is something you'll have to work on, like really bad. State the domain. We are running from -6 to 3. All right. Brackets on those. And then we're running from -3 to 2. Parentheses on those because of the open holes. And then we're running from 2 to, looks like where the x value is 6. Now this could actually be shorthanded a little bit. There's this overlap here. All right, there is technically there's no gap on x right here, because if you say what is f of 3, bam, it's going to find it. I also have to add a question onto this thing too, because it needs to be addressed. We'll say find f of 1, or no, f of, anyways. We'll do something like that for 20. So if I made this multiple choice, I would actually write this as -6 to 2. Because the hole is closed. You can ask this thing what f of -3 is. In fact, that's what I'll make that question down there. Find f of -3. It's fine. And union with 2 to 6. I can't say -6 all the way to 6 because there is nothing at 2. It's a hole there. All right, 14. Find the range of the piecewise function. So this is kind of interesting. You know, this piece right here, it has a range of -5 to -3. Then you got this piece right here, which goes from -3 all the way to 1. Those can be put together because there's no overlap. See the brackets? I mean, there's no gap. There's no absence of a y value. So this little piece, when you talk about this piece and that piece, they cover legit -5, apparently I can't count, all the way up to, that should have been in parentheses, all the way up to 1. It's really close. And you got 1 being defined. Notice anywhere on this line it's actually 1 because of that gap. Turns out everything is covered. There's actually no skipping around on this graph. It's -5 to 1. You kind of have to do a piece by piece deal and then put it all together. And oh, yeah, it got closed. It did get closed. While there's holes there at the end for this piece, and there's a hole there at the end, it's covered on the inside. The y value of 1 is established. All right. What's up next? State the intervals where the graph is increasing. That is happening right here. This is a positive slope. It is increasing for x values. Sorry, it's increasing right here because that's a positive slope for x values between -6 and -3. I am decreasing here. And the x values are from 2 to 6. Constant, that's your horizontal line. You literally have 0 slope. That happens here from -3 to 2. Because those are the x values that draw it. X-intercepts, there's one right here. It's at 3, 0. Number of kids who can't find an x-intercept is very disturbing to me. Like, it's really disturbing. I don't get it. Here's your y-intercept. She's at 0, 1. And 19 is determined the average rate of change over an interval from 1 to 6. So when x is 1, I'm right here on the graph. And when x is 6, I'm right here on the graph. All right? If I think about this, I fell 4. And I ran 5. Falling is negative, so negative 4/5. That's my average rate of change. And I've got to add these in here because they need to be there. F of negative 3 and F of 2. All right, F of negative 3. So you are literally letting X be negative 3, and you are finding the output Y. When X is negative 3, I have a choice. I can be up here where there's a hole, or I can be down here where there's not. I have to be here, the closed circle. So F of negative 3 is, in fact, negative 3. All right, it also says find F of 2. So I go to where X is 2 and I look at the graph, and there's a hole there. F of 2 has no output because 2 is not in the domain of the function. See up here where you encapsulated 2 in parentheses? It was not part of the function's domain. There was a frickin' hole in the graph there, and there wasn't another piece that closed that hole. All right, bonuses. Solve for X. This is the zero product property. You take a finger and you cover up. 2x minus 5 is 0, or 3x plus a quarter is 0. You add your 5. These are two-step equations. They do these with you when you're in middle school. You divide by 2, you get 5 halves. Or you subtract. 3x is negative 1 over 4. If you're going to divide by 3, just put a 3 in the denominator. 4 times 3 is 12. So negative 1/12. There's your two answers. Solve by factoring. Now it says solve by factoring. It doesn't say factor. It says solve by factoring. 7x squared minus 27x minus 4. This is the reverse of the double distributive property for a trinomial. Factors of 7x squared or 7x and x. Factors of 4, 1 and 4. I'm using guess and check. The outside makes 28. The inside makes 1. Negative 28 plus 1 is the negative 27 I need. I'm equal to 0. Now I use the combination. I go back and I think about how I did the first bonus. I cover up. 7x plus 1 is 0, or x minus 4 is 0. I subtract 1. 7x is negative 1. I divide by 7. I get negative 1/7. Or x is 4. And bonus 3, which will be worth more than bonus 1 or 2, is a standard in the math class above this one, which is pre-calc or dual enrollment. And it should be a standard in Algebra 2. Anyways, you're supposed to find what's called the difference quotient. You do that by doing f of x plus h, taking away f of x and putting it all over h and simplifying. It's not a hard problem. But the first thing it wants is f of x plus h. And I find f of x plus h by letting every x that I see be x plus h. If you haven't taken calculus, you'll appreciate the fact that I'm going to do this with you quite a bit. If you want to square x plus h, you're going to write it twice. I'm just going to do that down here. And you're always going to get the same thing when you square x plus h. You can get x squared plus xh plus hx plus h squared, which is always going to be x squared plus 2xh plus h squared. Always. It doesn't change. But what do I know? It's not like I've done this 1,000 times. I'm sure you know how to do the distributive property. And then we distribute the 2. So a lot of kids think this is tedious. A lot of kids who work at McDonald's tell me they're never going to use this math. You're right. You work at McDonald's. And there's nothing wrong with that. Somebody's got to. Anyways, that goes there. So 2x squared plus 4xh plus 2h squared. And that is the problem with America. We make everybody learn this math that they don't need. And it says take away f of x. So I have to take away this entire function. So I'm taking away all of 2x squared plus 3x minus 3. Notice I wrapped. If I don't wrap, I'll probably miss it. There's always cancellations here. You have a 2x squared minus a 2x squared. If there's 3 things here, you're going to cancel out the same 3 things over here. There's a 3x minus a 3x. There's a negative 3 minus a negative 3. So 3 things disappeared. We're left with 4xh plus 2h squared plus 3h, all sitting over an h. There are 4 terms in this rational expression. They all possess an h. So I get to divide it out of each piece. And that is the final answer. Have fun with that. Figure it out. It's not that bad. If you can do that, you can do anything else. I promise you.